Well, basically, what the IPM creates is an alternating current. How does it create it? Well, we've been talking a lot about how it synchronizes the gates to open. Finally, it ends up creating a three-phase alternating wave. Let's see if we can draw it correctly, as follows. Okay. This is not how it creates it. This is what the motor understands. In reality, what the IPM is going to create are pulses, always of the same height. In reality, it does not create a sinusoidal wave, but rather it creates pulses that the motor eventually understands as sinusoidal waves. So, we're going to draw it like this so we can understand what we're going to see later on the oscilloscope. One detail I want to mention is that the peaks of these waves are always 310, and that is because we have 220 volts. These are always the peaks, even if they don't show up in the drawing. The peaks are always those. And now we're going to erase the sinusoidal wave that is not actually there. And something like this is created. Electrons enter, exit through different paths. The same in another time. And the same in another time, which would represent the red. This is what makes the inverter motor rotate. And this varies in frequency and becomes shorter, wider, shorter, wider. Okay, we're going to see it with the measurement we're going to see now. Look then, measuring with the oscilloscope a working compressor. Let's see if we can see. We're going to place the oscilloscope between two of the points, between V and U. V and W are the same. And we're going to turn it on. We can see how that frequency is starting to be created through pulses. It doesn't look good there, but we're going to press the automatic key and calibrate the time. And we're going to put it in a position where we can see and understand everything we were explaining. We're changing the time that the oscilloscope shows. It looks much better there. We're only seeing one phase, because this oscilloscope is only one channel. If we placed it in any of the other forms U, V, W, in any way, we would see the same, but at different times. Notice that the frequency at which it is working is actually almost 1000 Hz. What is commercially said that an inverter works with 15 to 120 Hz, well, in reality, it is something commercial. In reality, the frequency that the IPM generates is higher and ultimately ends up creating a sinusoidal wave of less frequency. What this is measuring is each pulse. We can see it better there. This cannot be measured with a multimeter. The output of the IPM cannot be measured with a multimeter. I'm going to show you now in a slightly more stable video how the compressor accelerates and decelerates. There we have it running at minimum revolutions. It's a long video, so I'm not going to play it in its entirety. But notice how the time it takes from one wave to the next shortens. We put more cold on the equipment so that it spins faster. We ask for more cold. And notice how it starts to shorten. They start to be closer together. That is, the simulated sinusoidal wave that is created gets closer. And there we would be almost at maximum speed. We are always respecting the RMS voltage. It is always respected because it is an average. Because a simulated sine wave is eventually created. The maximum is 324. We are well at 310, only that there was a little more than 220 at this moment and peak to peak 650. The voltages are always the same. The voltages are the ones that enter through the line of your home if you go back to the class where we measured the rectifier bridge. The values are the same, only now, through pulses or square signals, we are creating a sine wave that we can modify the time. And then the compressor starts to run slower again. We again make it slow down its speed. There it slows down again, let's see. I don't remember well, but I think we stop it here. We stop it at minimum speed. And now the compressor stops. There we run the time to be able to see better. And there it is off. Well, and there we have the compressor. In fact, no, it hasn't turned off yet. I'm wrong. The compressor is still running. What we are doing is changing the time with the keys of the multimeter of the oscilloscope. We are changing the time. That's what we're doing. But well, the idea was well seen. So, as the compressor running slower has a more distant simulated sine wave, and once we start accelerating we have it much closer together. Well, I'm going to let the video run a little so you can appreciate the acceleration a little more, but in real time. We will see from here, and we will leave a few seconds so that you can observe. The only way to be able to see this is with an oscilloscope. A multimeter does not give me this possibility. A normal multimeter gives me the possibility of measuring direct current or alternating current, but 50 to 60 Hz. Only an oscilloscope gives me the possibility of visualizing and understanding this. And that is why only an oscilloscope is going to give me the possibility of being able to detect, in case of failure, if the problem is the motor or the board. I can only do it with an oscilloscope. This is the work of the Intelligent Power Module. Please leave a comment if you have any questions.